All right, the 10th unit in honors geometry is on area, and we're going to start off with what should be mostly a review of area formulas from elementary school, although there are a couple of new formulas. All formulas in this unit have to be memorized. You will not be provided with a formula sheet or any kind of note card or other device to help you with this. Your learning target today, I will find the area of triangles and quadrilaterals. So our essential question, how do I find the area of triangles and quadrilaterals? What are the area theorems? Now, the very first one we're going to discuss is actually a postulate. And I want to pause for a moment and ask you, what is the difference between a postulate and a theorem? Hopefully, you remembered that a postulate we accept without proof. A theorem is something we can prove. That's an important set of definitions that I guarantee you are going to show up on the SOL and the final exam. So the area of a square postulate states that the area of a square is the square of the length of its sides, or A equals S squared. Now this is a capital A, and this is a lowercase. Okay, and uppercase and lowercase really matters. The area congruence postulate states if two polygons are congruent, then they have the same area. The area addition postulate states that the area of a region is the sum of the areas of its non-overlapping parts. This is the postulate that let you take shapes like this in elementary school, and your teacher told you to draw in that segment so that you had two rectangles you were adding together, or she told you to fill in the corner and find that entire rectangle and then subtract out the red rectangle. Either way works. Now we have the area of a rectangle, and the area of a rectangle, capital A, is the product of the base times the height, lowercase b, lowercase h. Remember that base and height have to be perpendicular to each other. The area of a parallelogram, capital A, equals the product of the base and the height, lowercase b, lowercase h. Again, base and height have to be perpendicular. So in a parallelogram that is not a rectangle and not a square, height cannot be a side. This gives us the opportunity to pull in some beautiful information about right triangles when you have to solve problems on tests and quizzes. Area of a triangle, capital A again, equals 1/2 lowercase b, lowercase h. Again, the opportunity for some beautiful right triangle theorems come into play. Area of a trapezoid, capital A, equals 1/2 parentheses, base 1, base 2, the sum of the bases, and multiplied by the height. Okay, so don't forget that the height of a parallelogram is not the leg unless it's a the height of a trapezoid is not a leg unless it's a right trapezoid. Okay, so watch that. Height has to be perpendicular. Now this one's new, so I'm going to draw your attention to it because up till now you're probably bored. But area of a kite equals 1/2 the length of the first diagonal times the length of the second diagonal. Okay, remember that diagonals in a kite are perpendicular to each other. So again, we have the potential for a whole bunch of right triangle stuff, including trigonometry, in the problems we assign you. And here is a new formula for area of a rhombus. You can use base times height if you have that information. Otherwise, we can also use 1/2 diagonal 1 times diagonal 2. Okay, and this works because the diagonals are perpendicular, just like they're perpendicular in a kite. All right, so let's get some practice in. Find the area of parallelogram ABCD. So my formula is base times height, and I know base and height have to be perpendicular to each other. Let's see. Looks to me like my height here is 9, and my base is the parallel side on top, which is 20. So area equals 20 times 9, or 180. Did they give me any units in this problem? No, so I'm going to put units squared. Remember, area is in squared units. Find the height of a triangle that has an area of 18 and a base of 8. So area of a triangle is 1/2 base times height. So that's going to be 18 equals 1/2 times 6 times the height. Well, half of 6 is 3. And 18 divided by 3 is 6. Again, no units in the problem, so I'm just going to put units in my answer. Find the area or height of each polygon. We've got a rectangle based on the way this is marked. So area equals base times height, which would be 4 times 8, 32 units squared. There's the potential for a lot of algebra here. I could make this x plus 8 and x plus 4 and make you factor. Okay, and solve a quadratic. So be careful. Alrighty, we've got a triangle. So area equals 1/2 base times height. 1/2, 9 times 16, half of 16 is 8 times 9, 72 units squared. Again, not hard to make these more challenging. I could tell you you've got a 60-degree angle here and make you solve a 30, 60, 90 triangle in order to complete the problem. We've got a trapezoid. Area equals 1/2 the sum of the bases times the height. So 1/2, 14 plus 6 times 7. 14 plus 6 is 20. Half of 20 is 10. 10 times 7 is 70 units squared. We have a rhombus. They did not give us base and height. So we can solve this using our diagonal theorem. Area equals 1/2 diagonal 1 times diagonal 2. So half. The first diagonal is 22, and the second diagonal is 16. So let's see, half of 16 is 8. 8 times 22 divided by 2, 176 units squared. Okay, I've got a parallelogram. So area equals base times height. I know my area is 60. My base is 6. My height is 10. So my height is 10 units. And finally, I've got a kite. So area equals 1/2 diagonal 1 times diagonal 2. Let's see, that's going to be 1/2. This diagonal is 18, but this diagonal is labeled out here, it's 40. So half of 18 is 9. 9 times 40 is 360 units squared. Okay, we can make this a lot more complicated just by throwing some algebra into the mix. Also by throwing in 30, 60, 90 or 45, 45, 90 triangles with all of these perpendicular heights. We can pull in the Pythagorean theorem. So don't think they're all going to be this easy. You owe me a summary.